Hey everybody, today we're going to do the Unit 9 Workshop Day 3 notes. Some of you will be listening to this Tuesday night at home, and some of you will be listening to this in the Wednesday workshop where Miss Ellis is filling in for me. We're going to be looking at first identifying all the graphs of the trig functions. We've already looked at sine and cosine in detail, but now we need to look at tangent, cosecant, secant, and cotangent. And today I really just want you to be able to recognize them, and then tomorrow or Wednesday in the session, you're really going to be doing these in the calculator. So if you're asked to graph something and you have a calculator with you, you can easily graph it in the calculator to get a visual, okay? But for now, I just want to give you an idea of what each of these graphs look like from 0 to 2 pi. So first we'll look at tangent. I'm going to graph them from 0 to 2 pi. So pi is here, 2 pi is at the end. Each of these four graphs are going to have asymptotes. Tangent has an asymptote at 90 degrees, and 270 degrees. And then the graph looks like this. Okay, this is just a sketch. It doesn't have to be perfect. You have to just be able to recognize it. Cosecant of x, that one is going to have an asymptote at pi. And then it's going to have these two almost parabola-looking graphs. Then for secant, we're going to go from pi and 2 pi. The asymptotes, just like tangent, are at 90 and 270. And then we have the piece of the parabola here, a full parabola in the middle, and another little piece here. Okay, you should be getting these graphs down on your paper as well. And then finally, cotangent is going to have an asymptote at pi, and is going to look approximately like that. Okay, so sketch those graphs, and again tomorrow you're going to answer some questions like this that say which graph represents the equation f of x equals secant of x. If I was doing this question on a test, all I would do is go to my graph, type in secant of x, hit graph. You'll see tomorrow that there is a trig window button you can use, and then you're literally just matching to that. So if you were to type that in and match, it would come up looking like, my apologies, choice 3. Okay, next we're going to look at the inverse trig functions and what the graphs of those are going to look like. You might see it written as y or f of x equals sine negative 1 of x, or y equals r sine x, and same thing for the other two inverse trig functions. So inverse sine, okay, if you remember, these come from switching the x and the y. So if we graph this here, it's going to look approximately like that. Okay, inverse cosine is actually only going to be up here in quadrants 1 and 2. And then inverse tangent is going to go from negative 2 pi to 2 pi and look like this. Okay, in order for the inverse functions to actually be a function, we have to restrict our domains for the original functions sine, cosine, and tangent in order for those to be one-to-one and the inverse to be a function. So this you really just have to memorize. You need to memorize it so that you can answer some multiple choice questions related to this. So you need to memorize, you need to write this down, that the restricted domain for sine of x is a domain from negative pi over 2 to pi over 2. And we use less than or equal to signs because it can include negative pi over 2 and pi over 2. For cosine of x, the restricted domain is from 0 to pi. And for tangent of x, the restricted domain would be negative pi over 2 to pi over 2, but it does not include negative pi over 2 and pi over 2, so you'll see I just used less than signs, okay? You need to circle, box in, that you need to just memorize this. If a question comes up asking you about restricted domains, you need to have this memorized so you can look for the correct answer, pick it, and move on. So here's a couple of those multiple choice questions that I was telling you about. If you look at this first example, the function f of x equals tan x is a one-to-one function over which of the following domains. So I look back at what I memorized, and I have in my brain that the only time it's one-to-one is if tangent of x is from negative pi over 2 to pi over 2, but it can't include those, so I want the one with less than signs, not less than or equal to signs. So that would be choice 3. Okay, look at the next example. The function f of x equals sine x is defined in such a way that f inverse of x is a function. My bad. What can be the domain of f of x? So again, I look back, I've memorized that the only way the inverse can be a function is if the domain for sine of x is negative pi over 2 to pi over 2, and it includes those, so it's choice 4 with the less than or equal to signs. Okay, and then last one, again tomorrow, or today if you're watching this in class on Wednesday, you're going to go right to the calculator for this, and you're going to go to the graph, hit tab, type in inverse cosine of x, hit graph, and you should pick the one that matches. When you do that, you will see that you are going to get answer choice 3. That is the graph that matches inverse cos of x. No need to memorize those. You can use the calculator.